Okay, so the next thing we need to do, since we have found the components of A, so we've got AX and AY, then B, BX and BY, and C, CX and CY, we need to carry out these operations: A plus B, A minus B, B minus A plus B plus C, A plus B minus C. Okay, so for A plus B, we need to find out how much is A plus B along the x-axis and how much is A plus B along the y-axis. So you need to find out how much A plus B is along the x-axis and how much it is along the y-axis. For such an operation, this is carried out like this. So that is going to be AX plus BX. So in this case, AX is 14 meters, then BX is minus 15 meters. So we are going to add 14 meters plus minus 15 meters, and the result of that is minus 1 meter. This negative 1 meter shows that A plus B along the x-axis points in the negative x-axis. It points in this direction. Along the x-axis, A plus B points along this direction. It's negative. Okay. Then we move on to this one. How much is A plus B along the y-axis? And this one, A plus B along the y-axis, is given by this. That is AY plus BY, and AY in this case is 14 meters and BY is 26 meters. So that gives us 14 meters plus 26 meters, and we get 40. So that is how we get how much a vector is along the addition or the subtraction of a vector. How much is it along the x-axis or how much is it along the y-axis? We add the components. So we add AX plus BX of the vectors. So this gives us minus 1 meters. Okay. Then for the y component along the y-axis, it's AY plus BY, and we get 40 meters. Is this clear on how we find out how much A plus B is along the x-axis and how much A plus B is along the y-axis? For each vector, you need to know how much it is along the x-axis and how much it is along the y-axis. That has to be known. Okay, next we move on to this one, A minus B. That is also a vector because we are subtracting vectors. So you need to find out how much A minus B is along the x-axis and how much A minus B is along the y-axis. So in this case, A minus B is going to be equal, along the x-axis is going to be equals to AX minus BX. AX is 14 meters minus, then BX is minus 15 meters. So what you have here is 14 meters minus 15 meters, and that gives you 29 meters. So A minus B along the x-axis in this case is 29 meters. And how much is A minus B along the y-axis? For us to find out that, this is what you carry out. You subtract the components, AY minus BY. In this case, AY is 14 meters minus BY is 26 meters. So 14 meters minus 26 meters, you get minus 12 meters. Is that clear?
So let us say yes, sir.
Sorry? Is there a question? Huh? Okay, next. Vector B minus A. For each vector again, we need to find out how much it is along the x-axis. We need to find out how much it is along the y-axis. So for B minus A, The question is how much is b minus a along the x-axis and how much is b minus a along the y-axis. So b minus a along the x-axis is bx minus ax. Bx is 14 meters minus, bx is minus 15 meters, then minus ax is 14 meters. So we have got minus 15 meters minus 14 meters, and that gives us minus 29 meters. So this negative shows that b minus a along the x-axis points in the negative x direction and has got a size of 29 meters. Along the y-axis, b minus a is equals to by minus ay. By is 26 meters minus ay, which is 14 meters. So 26 meters minus 14 meters, we get 12 meters. So along the y-axis, b minus a points in the positive y direction. Is that clear on how we have done that? Is it clear?
I just have to fit him. Yes, it's clear. Oh,
okay.
no, sir.
Next, we are not restricted to adding or subtracting only two vectors. Depending on what situation you're given, you can even add or subtract more than two vectors. For example, in this case, you want to find the result of adding vector A plus vector B plus vector C. So when you add more than two vectors, like in this case, you want to find out how much the resultant A plus B plus C, which is a vector, is along the x-axis and how much it is along the y-axis. So how do you do that? You add the components of the vectors ax plus bx plus cx. So this gives you how much A plus B plus C is along the x-axis. So ax is 14 meters, then you have a plus, then bx is minus 15 meters, then plus cx, which is minus 10 meters, and you end up with minus 11 meters. So A plus B plus C along the x-axis has a size of minus 11 meters. It's pointing in the negative x-axis. Then, how much is A plus B plus C along the y-axis? So you find that by adding the y components of these vectors. So that is AY plus BY plus CY. So AY in this case is 14 meters. Then plus BY 26 meters. Then plus CY is 0. So 14 meters plus 26 meters plus 0, that gives you 40 meters. Then you can do, you're not restricted only doing addition, you can do a combination of addition and subtraction if that's what you want. So in this case, for A plus B minus C, this is another vector, and we need to find out how much this vector is along the x-axis and how much it is along the y-axis. So in this case, A plus B minus C along the x-axis is going to be AX plus BX minus CX. This AX is 14 meters, then BX is minus 15 meters, and CX is minus 10 meters. So 14 meters plus minus 15 meters minus 10 meters, and that gives you 9 meters. So A plus B minus C along the x-axis is 9 meters. We also need to find how much A plus B minus C is along the y-axis, and that is going to be equals to AY plus BY minus CY. So AY is 14 meters plus BY is 26 meters minus CY, which is 0 meters. You end up with 40 meters. So for the last vector, both the vector along the x-axis points in the positive x direction. Along the y-axis, it also points in the positive x direction. So this is how, for any vector, whether it's a plus b, or a minus b, or b minus a, or a plus b plus c, or a plus b minus c, this is how you find how much that vector is along the x-axis and how much that vector is along the y-axis. It's important that you're able to find how much a vector is along the x-axis and the y-axis, because we use these components, how much the vector is along a direction, to find the size of the vector, and later on to work out what is the angle which the vector makes with the positive x-axis. Do we have any questions before we proceed from this step? Are there any questions?
So that,
Yes.
does that mean that? Yes, now you've hidden the slide. Yeah. Do you mean that when we're finding a and the x-axis or the y-axis, we always use the meters?
We always use what?
The meters.
Yes, all calculations about length in physics are done in meters.
Okay.
Any length calculation in physics is done in meters. Any other question?
So how about if the vectors are dealing with forces?
You do the same thing. Well, it doesn't matter, because it's a vector. Whether it's force or it's displacement, it's a vector. You have to find how much is the vector along the x-axis, how much is the vector along the y-axis. You do the same thing. You do the same step. Whether it's displacement or it's force, it doesn't matter. It works for all vectors. Any other question? Okay, so if there are no other questions, now that we have worked out how much each of these vectors, a plus b, a minus b, b minus a plus b plus c, a plus b minus c, is along the x-axis and along the y-axis, we are going to use this information to work out the size and the direction which these vectors make with the positive x-axis. We are going to start with vector a plus b. We know that a plus b along the x-axis is -1 and along the y-axis is 40. So we're going to find the size of this a plus b as follows. So here, so the magnitude of a plus b, which we write like this, is given by this. So a plus b, the size of a plus b is equal to the square root of this ax plus bx squared plus ay plus by squared. Ax plus bx from the table here, ax plus bx here, ax plus bx is -1 meters and ay plus by is 40 meters. So we substitute for those values. We always square the components of the vector we are interested in. So the vector we are interested in is a plus b. How much is a plus b along the x-axis? This is a plus b along the x-axis. How much is a plus b along the y-axis? That is a plus b along the y-axis. So that is -1 meter squared, then plus 40 meters squared, and that gives us 1,601 meters squared. Then we take the square root of that, we end up with a size of 40 meters. So a plus b has got a size of 40 meters. Are we clear?
Yes, sir.
Next, we try to plot how much a plus b is along the x-axis and how much a plus b is along the y-axis, and where a plus b is supposed to be on an xy plane. So here, so this is the xy plane, so plus x, this side minus x, plus y minus y. So ax plus bx minus 1, this is along the x-axis here, it's -1, very small here. Then the other one, ay plus by, that is equals to 40 meters along the y-axis. That one, the red line along the y-axis. So there's the red line along the y-axis. There is this other vector at the bottom here, ax plus bx along the x-axis, which is -1. The other one is 40 meters. Okay, so you can see that the y component of a plus b is along the y-axis pointing up. The x component is along the negative x-axis pointing in this direction. So if you get this, the y component, you put it at the end of the x component. If you get this, you shift this and you put it along this dotted line. You have not changed anything because the size still remains the same, 40 meters, and the direction in which it is pointing has not changed. It is just parallel to the y-axis. So if the size is still 40 meters and the direction in which the vector is pointing, the ay plus by is pointing, is the same, then we have not changed anything. It is still the same vector. Is that clear? You can move a vector around as long as the size and the direction does not change. If the size and the direction do not change, then we are still talking about the same vector. So when I get this vector ay plus by, which is equals to 40, I shift it to the end of ax plus bx, so I can move like this. I can move this way, then I can move along that dotted line, which is the ay plus by up to that end. That is the same as moving from here along this green line up to that point. So this dotted line here is the y component of a plus b, and this line at the bottom is the x component of a plus b, which is -1, and the other one there is 40 meters, which is a plus b along the y axis, and this green line is the vector a plus b. Is that clear?
Yes, sir, it's clear.
Okay, so now that we have a general idea of where a plus b is, that it is in this second quadrant of the xy plane, we need to find a precise angle. We need to find the precise angle a plus b makes with the positive x-axis. So we measure from the positive x-axis like that up to where a plus b is, and the angle is going to be theta. Alberts, can you switch off your microphone? Okay, the angle is going to be theta. This is the angle we are looking for. This is the angle we are looking for. We're looking for this angle theta. Now, the way this vector is, okay, in the second quadrant, it is not possible for us to directly, find this angle theta from the information we have. We have ax plus bx equals to -1 along this line. Then we have ay plus by along this dotted line, which is equals to 40 meters. However, if you look carefully at what we have, if you move along the x-axis, which is -1 meter, then you move along the y-axis, which is 40 meters, then you move along this yellow line. This yellow line, we have found the size of this yellow line, which is a plus b. It is approximately equals to 40 meters. what you have here is a right angled triangle. And this right angled triangle which you have here, this dotted line is the opposite, then the line at the bottom here is your adjacent, then the green line is your hypotenuse. Okay, this triangle makes an angle with the x-axis. This triangle makes an angle with the x-axis, the negative x-axis, and that angle is what we have shown inside here as phi, the angle of the triangle, phi. If you look at this setup which we have, so we have an angle phi which is inside the triangle we have created out of the two components and the hypotenuse. Then you have got theta. So these two angles, phi plus theta, they should add up to 180 degrees. So we are going to use this information that phi and theta should add up to 180 degrees. We're going to use this information to find theta. The first thing we're going to do that is we need to work out what this angle phi is. We need to work out what this angle phi is. So we have a triangle. We know the adjacent is -1 meter. The AX plus BX is -1 meter. We know that the opposite AY plus BY is 40 meters. So we can use this information that the opposite AY plus BY is 40 meters. The adjacent AX plus BX is -1 meter to find the angle phi, which is the angle of the triangle we could form from the hypotenuse and these two opposites and the adjacent. Is that clear on what we are trying to do? We are trying to find theta indirectly by first finding phi, then we can later move on find theta.
Yes, sir.
So the next step is to find phi. So we're going to write tan phi is equals to the opposites, this side, which is the AY plus BY, that is 40 meters, divided by the adjacent, which is AX plus BX, which is -1. So tan phi is equal to the opposite, AY plus BY, divided by the adjacent of the triangle, which is AX plus BX. The AY plus BY is 40 meters, divided by the adjacent, which is -1 meter. So 40 meters divided by -1 meter gives you -40. So tan phi is equals to -40. Then we can work out phi. So phi is equals to the tan inverse of -40. And if you work that out, you should get phi being approximately equals to -89 degrees. Now, phi is negative, -89 degrees. The question is, what does it mean that you've got an angle which is negative? As you can see from what we have drawn here, the two angles phi and theta have different they are moving in different directions. Phi is starting from the negative x-axis going in the clockwise direction. Theta is starting from the positive x-axis going in the anti-clockwise direction. Remember, we said that all angles are measured in, if an angle is measured in, by convention, angles are measured in an anti-clockwise direction and they are positive. So if you measure an angle in a clockwise direction from anywhere, if you measure your angle from a clockwise direction, that angle is going to be negative. As you can see, we are measuring our phi from the negative x-axis, and the angle the negative x-axis makes with the positive x-axis is 180. So we have got 180, then we're going backwards in the negative direction, 180 going backwards, and that's how we end up with theta. So the way we're going to work out theta is as follows. So theta is going to be equals to 180 degrees plus phi. However, as we can see, our phi is negative. So it's going to be 180 degrees plus minus 89 degrees. And that is going to give us a theta, which is equals to 91 degrees. Is this clear? Sorry? You
Why
measure,
are you saying 180 plus?
you are measuring phi from 180 degrees. Look at the diagram here. You're starting from here. This is 180 degrees. 180 degrees plus phi. But it so happens that phi is negative. You're starting from the negative x-axis. The negative x-axis has a value of the angle the negative x-axis makes is 180 degrees. So 180 degrees plus phi, that's what gives us theta. So in this case, phi is negative and we end up with theta, which is equals to 91. From the positive x-axis going around like this up to the negative x-axis, the angle is 180 degrees. At least that much I know. I know that the negative x-axis makes an angle of 180 degrees. So whatever 180 degrees plus phi should give me theta. Is that clear?
Clear.
Okay. So that's how you find the size of A plus B, and also how you work out the angle. As long as the vector is not, as long as the vector is in the second quadrant, in the third quadrant, and in the fourth quadrant, you need to work out phi. Because in those quadrants, phi, the angle of the triangle you form from the components and the vector itself, is not the same as theta. Phi and theta are only the same in the first quadrant. So in the first quadrant, the angle of the triangle and theta have got the same size. That's why in the first quadrant here, you only work out theta, or you can work out phi, but it's going to be phi plus 0 because you will be measuring from this side. Okay? And that is going to give you your value of theta. So theta plus, as we are going to see, theta plus 0 gives you phi. Sorry, phi plus 0 gives you phi, theta. Next, we move on to the next vector. The next vector is A minus B. A minus B. A minus B, as we can see from the table here, A minus B along the x-axis is 29 meters. A minus B along the x-axis is 29 meters. So along the x-axis, it's pointing along the positive x-axis. Then along the y-axis, it's pointing in the negative x direction. It's minus 12 meters. So with this information, A minus B along the x-axis 29 meters, along the y-axis minus 12 meters, we can work out what should be the size of A minus B. So the size of A minus B here, the magnitude of A minus B is going to be equal to the square root of how much A minus B is along the x-axis squared plus how much A minus B is along the y-axis squared. So along the x-axis, A minus B is 29 meters, so you square that, plus along the y-axis, A minus B is minus 12 meters, we square that, and that gives us, when we add the things at the bottom here, we have 985 meters squared. Then you obtain the square root, you end up with A minus B having a size of 31.4. So A minus B has a size of 31.4 meters. Is that clear? On how much A minus B is?
Yes, sir. Yeah, that. My question, sir.
Yes, go ahead. We are waiting for the question.
To the other side. Now, what's the on that? The angle has been moved from negative acceleration. What? Yes. What makes the angle to change? What determines, like, in terms of negativity, can the direction has changed?
What makes the angle to change? You have to draw this triangle. You have to see what the triangle looks like. Where is it pointing? Where is the vector pointing? Which angle are you talking about? This or this?
The other ones are.
Which other one? Is it the angle inside the triangle or the theta?
Down there.
Sorry?
Oh, the triangle. The triangle, sir.
Yeah, so what about the triangle?
The other triangle.
Which other triangle? This one or the other? Which other triangle are you talking about?
At the top. Again, it went down there. Not the first one, the second one, sir.
This is the first image we have. Then the second one. Then there's a third one coming down here. There's a third one here. So which one are you talking about?
Okay, sir.
Ati?
Yes. The third one.
Yes, what about the third one? What's the problem?
The third one, sir.
What is the question about the third one?
Okay. I've understood the concept, sir.
I don't know what you have seen
The
because
movement of the triangle from that position to the other position.
so we next come to basically I think the problem is you are trying to, I don't know what we're trying to move ahead or something like that. That's creating confusion with where we are. So after we find the size of A minus B, which is 31.4 meters, the next thing we need to do is we need to find the direction in which the vector A minus B is pointing. Okay, so we plot this, the x component, how much is A minus B along the x-axis, that is 29 meters, and how much is A minus B along the x-axis, along the y-axis, that is minus 12 meters. So when we sketch our xy plane, so here, plus x, then minus x, plus y, minus y. So along the x-axis, that's where we have the ax minus bx, which is equal to 9 meters. This line here, there. That line is 29 meters. Then along the y-axis, we have ay minus by, and that is minus 12 meters. The minus is because it's pointing in the negative y direction. So we have along the x-axis a minus b, so, and if we get this, so along the x-axis, this is our ax minus bx, 29 meters. Along the y-axis, we have our ay minus by, which is minus 12 meters again. So we have got these two components. If we get this one, ay minus by, we shift ay minus by to the end of ax minus bx, so that we move, and it's going to become this dotted line. We have not changed anything because the size is 2 minus 12 meters, and the direction in which it's pointing is the same as the negative y-axis. So the direction is the same, the size is the same. So ay minus by has not changed. You have just shifted it to where it is. So if you shift it like that, then you move along the x-axis up to the end of ax minus bx, which is 29 meters. Then you move down minus 12 meters. You end up here. When you end up here, it is the same as you moving from that point all the way up to here. So this green line is our a minus b. This green line we have here. This green line represents our a minus b. With the shifting we have done, we have this bit, which is 29 meters along the x-axis. Then we have the minus 12 meters along the y-axis. Then we know how much a minus b is, because we are just from working out a minus b. It is 31.4 meters. A minus b is 31.4 meters. We are just from working it out. With that 31.4 meters, you realize that when you do that, you have this 29 meters on the x-axis. Then you have this shifted y component. Then you have your vector a minus b. What you have is a triangle again. A right angled triangle. What you have is a right angled triangle. So with this triangle, our interest is what is the angle this triangle, this A minus B, makes with the positive x-axis. Again, we measure this angle theta from the positive x-axis in an anti-clockwise direction. We move like that. So this angle from there, we move around like that up to where this vector is. That is our theta. That is the angle we are interested in. That's the angle we want. Okay. However, from the makeup of the triangle, like this, you also see that there is a small angle inside the triangle here, which is measured from the x-axis, positive x-axis, going down like that. That is the angle phi. So if the angle we are looking for theta is measured from the positive x-axis going around like that up to the where the vector is, then there is an additional angle here, phi. We see that when you add the phi to theta, what we end up with is actually theta plus phi being equals to 360 degrees. We are going around like that up to there. So this line along the x-axis, if you measure from the x-axis, then you're moving clockwise, backwards. Basically, you will be moving 360 degrees plus this phi. So we need to find the angle phi. Then after we find the angle phi, we're going to add the angle phi to 360 degrees so that we can find theta. We can find the angle phi from the components ax minus bx, because the adjacent is known, that is 29 meters, and the opposite is also known, that is minus 12 meters. So we proceed to work out what is the value of phi in this triangle. Once we find the value of phi in this triangle, we are going to add that value of phi to 360 degrees so that we can find what theta is. And that's what we are going to do here. So tan phi here, tan phi is equals to ay minus by. So ay minus by, this one, that is the minus 12 meters divided by ax minus bx, which is the 29 meters there. So ay minus by is 12 meters, then divided by 29 meters, and if you do that, you end up with minus 0.41. The tangent of phi is minus 0.41. Then phi itself is going to be tan inverse of minus 0.41, and that is going to give you an angle of phi which is approximately equals to minus 22.3 degrees. So our phi is negative 22.3 degrees. The reason why it is negative is because this phi is measured clockwise. Angles measured in an anti-clockwise direction are positive, but we are measuring this angle phi from the positive x-axis. The angle theta is always measured from the positive x-axis, then you move in an anti-clockwise direction. The angle phi, which is the angle of the triangle you make, is always measured from the x-axis. That x-axis can be the positive x-axis or it can be the negative x-axis. So if you're measuring from the x-axis, depending on where the triangle is, right now the angle is closer to, is being measured from the positive x-axis, but it's being measured in a clockwise direction, coming down like this. Clockwise angles are negative. That's why you have your value of phi being equals to negative 22.3 degrees. It shows, the negative shows you the direction in which you need to move from the x-axis. You need to move clockwise from the x-axis which is there. Okay, so in this case the x-axis makes an angle here 360 degrees. Then 360 degrees plus phi, that is what's supposed to give you theta, and that's what we do here. So theta is going to be equal to 360 degrees plus phi, and that is going to be 360 degrees plus minus 22.3 degrees, and you end up with an angle theta which is equal to 337.8 0.7 degrees as our theta. Are we clear? Are we clear? Any questions?
Yes, sir.
What are the questions? Excuse me? Did
No questions, sir.
hello?
Okay.
Kina anda and that's the number. Fine, I'm actually. Okay. All right. Do you have any questions?
Sir, I have a question. I saw a post on Moodle saying we're going to write a quiz on the 7th of April. Is it true?
Is it there on Moodle? If you saw it on Moodle, then it should be true. Next, I'll check to confirm. Let me just check even now if we can do that.
No question.
Okay, just a minute. Announcements. Okay. Just a minute. Under what topic was it? The quiz?
It was under, it was main code, it's under the messages when you go to the chats on Moodle.
Why would they put a post under the charts? Because that's supposed to be a public thing.
It's written vectors, yeah. Okay.
It's written vectors. Oh, okay. Well, I haven't seen such a message.
Yes, the vectors and units. Okay, sir.
Just a minute. No, I'm not seeing anything. I'll ask around next week. Okay. Next, I think we need to finish this so that we move on to other things. Next is vector b minus a. So b minus a along the x-axis has got a size of minus 29 meters. Then along the y-axis has got a size of 12 meters. So for b minus a, with along the x-axis being minus 29 meters and along the y-axis being minus 12 meters, we can find the size of b minus a. Okay. So here, so the magnitude of b minus a written like this is going to be, so b minus a is going to be the square root of how much b minus a is along the x-axis squared plus how much is b minus a along the y-axis squared. So along the x-axis, as you can see from the table, it's minus 29 meters, then squared plus along the y-axis is 12 meters squared. And that gives us 985 meters squared. Then you square root that, we get 31.4 meters. So you see something, b minus a has got a size of 31.4 meters. A minus b also has a size of 31.4 meters. A minus b has a size of 31.4 meters. So these two vectors, a minus b and b minus a, their sizes is the same. However, as you are going to see, these two vectors are not the same because the angles, the theta for a minus b and b minus a are not the same. The angles are different. Okay, we're going to find that the angles are different. So we are going to plot next, after we have found the size for b minus a to be to be 31.4 meters. The next thing we're going to do is we plot the x components and the y components. So bx minus ax is minus 29 meters. That's what you've drawn here. It's negative, so it's pointing along the x-axis. Then by minus ay is 12 meters. It's positive, so it's pointing up like that. So we get this y component, we shift it and we put it at the end of the x component. So this is a dotted line we have shifted there. So if we move along this line, that is minus 29 meters for b minus ax, then we move along the y-axis, that is by minus ay, 12 meters, we end up at this point. This point where we end up is the same as us moving from the center here along this green line up to there. This green line is b minus a. This green line is b minus a. As you can see, b minus a, just from looking, is pointing in a direction which is different to the other vector we have just considered, a minus b. A minus b is pointing in the fourth quadrant, is located in the fourth quadrant. B minus a is located in the second quadrant in our case here. So already there is a difference. The size of a minus b and b minus a might be the same, but these two vectors are not located in the same place. Are we clear? Just by making this sketch, they are not located in the same place. Is this clear? The next piece of information we need for b minus a, since we know its size, is the angle b minus a makes with the x-axis, the positive x-axis. That angle is this angle theta. So we measure theta from the positive x-axis all the way up to where b minus a is. That is theta. Okay. However, the problem with theta is we cannot get theta directly from by minus ay from bx minus ax. We need another angle which is inside this triangle. So if you look at the x-axis, which is minus 29 meters, along this x-axis minus 29 meters, along the y-axis 12 meters, then we have got the hypotenuse here, which is 31.4 meters. We have a triangle in this space. So we need to work out what is this angle of the triangle, and that is the phi. Okay. This phi angle is always measured from the x-axis. It doesn't matter whether it is the negative x-axis or the positive x-axis, but it is measured from the x-axis. As you can see from what we have here, the angle inside the triangle phi and theta are not the same, but these two angles are related. They add up to 180 degrees. Okay? And the way phi is measured, you measure phi from the negative x-axis, then you're going in a clockwise direction. So we expect this angle phi to be negative. So we're going to get theta to be equals to 180 degrees plus phi, with a phi which is negative. So we're going to work out what this phi is using the y component, that is by minus ay, and using the x component, which is bx minus ax. So that is this. So tan phi is equals to by minus ay divided by bx minus ax. So when you do this, so tan phi is equals to, the thing on top is 12 meters, then the x component is minus 12 meters, minus 29 meters, and you divide them, you get yourself minus 0.41. And from the phi, you get phi as tan inverse of minus 0.41, and your answer is phi is equals to minus 22.3 degrees. So in both cases, phi is the same angle. It's minus 22.3 degrees. What this tells you, it's two different things. It is where you are starting from. From the x-axis, from this x-axis here, you move in a clockwise direction like that. From the x-axis, you move in a clockwise direction. That is what the negative direction is, minus 22.3 degrees. Are we clear? Hello? Is it clear? So with a phi of minus 22.3 degrees,
Yes, sir.
we add this phi to 180 degrees. So theta is going to be equals to 180 degrees plus phi. That is equals to 180 degrees plus minus 22.3 degrees, and you get yourself theta equals to 157.7 degrees. So that is what theta is. Theta measured from the positive x-axis. Your theta from here, from the positive x-axis, is 157.7 degrees. By using this phi inside the triangle here, you work out the phi inside the triangle, and you add it to 180 degrees, but the phi is negative because you're measuring it. You're measuring from the negative x-axis going in a clockwise direction. The angle of the triangle. Are we clear? On what we have done? Is it clear? Next, the next angle vector we have to look at is A plus B plus C. A plus B plus C along the x-axis, A plus B plus C is minus 11 meters. That is, it's pointing along the negative x-axis. Then A plus B plus C along the y-axis is 40 meters. So we can find the size of A plus B plus C. And how do we do that? So A plus B plus C, the size here, the size of A plus B plus C, like this, is going to be equal to the square root of how much is A plus B plus C along the x-axis, which is AX plus BX plus CX squared, plus how much is A plus B along the y-axis, which is AY plus BY plus CY, the whole thing squared. Along the x-axis, this is minus 11 meters squared, plus along the y-axis 40 meters squared, and we end up with, inside the square root, you end up with 1,721 meters squared. Then you square that, you end up with the size of 41.5 meters. So A plus B plus C has got a size of 41.5 meters. where is it located? What is the direction of the vector A plus B plus C? Along the x-axis, as you can see, it is minus 11 meters. Along the y-axis, it is 40 meters. So if you make a sketch of this A plus B plus C, so AX plus BX plus CX along the x-axis is minus 11 meters, so it's this way. Then along the y-axis, AY plus BY plus CY is 40 meters, so it's pointing in the positive y direction. So you get this y vector y component, you shift it to this dotted line, so you end up moving from here. You go down along the x-axis, then you go up along the y-axis, you end up at that particular point. That point is the same as you moving along this green line and ending up at that point. This green line represents A plus B plus C. That is the vector A plus B plus C. It is located in the second quadrant. Are we clear? Okay, I need people to speak, not writing text messages. I don't have time for reading your text messages. Next, we want to find out, we know how much A plus B plus C is. We have found out the size. It is 41.5 meters. We want to find the direction. So we always measure the angle. The direction to a vector is measured through the angle theta, is given by the angle theta, and this theta is measured from the positive x-axis in that direction. See? Again, the problem is the same. We can't get, if the angle is not located in the first quadrant and located elsewhere, we cannot directly get theta from the components of A plus B plus C, the x component and the y component. But again, we realize that with this x component, which is minus 11 meters, and the y component, which is 40 meters, and also the A plus B plus C, we have a triangle here. So this triangle has at the angle of the triangle, which is theta. That's the theta you have there, sorry, the phi you have there inside. And the phi and the theta are related to each other because phi plus theta is 180 degrees, as you can see. So what we are going to do is we are going to work out phi using the adjacent and the opposite, and once we find out what phi is, we are going to add phi to 180 degrees so that we can get theta. And that's what we do here. So tan phi is equals to AY plus BY plus CY divided by AX plus BX plus CX. So AY plus BY plus CY, that is 40 meters. Then AX plus BX plus CX, that is minus 11 meters. So 40 meters minus 11 meters, that gives you minus 3.64. Then we get the phi from this tangent. So the phi is equal to the tan inverse of minus 3.64, and that gives us a phi which is equals to minus 74.6 degrees. So we know how much phi is. It's minus again. The reason why it is minus is because you are measuring phi from the negative x-axis, then you're going in a clockwise direction. Whenever you are measuring an angle, then you're going in the clockwise direction, that angle comes out negative. So you're measuring from this negative x-axis, then you are going like this clockwise. That is negative. So for us to get theta, we need to add this phi to 180 degrees, then we can get theta. And that's what we do here. Theta is equals to 180 degrees plus phi, that is equals to 180 degrees plus phi, which is negative 74.6, and we end up with a theta which is equals to 105.4 degrees. Are we clear? Last but not the least is A plus B minus C. Go to the table. Here, A plus B minus C along the x-axis, A plus B minus C is 9 meters, and along the y-axis, A plus B minus C is 40 meters. So both the x component and the y component in this case are positive. So how are we going to find the size of this vector? Of course, like this. So the size of A plus B minus C is going to be equal to the square root of how much is A plus B minus C along the x-axis squared plus how much is A plus B minus C along the y-axis squared, and that is 9 meters squared plus 40 meters squared, and that gives us 1681 meters squared, and if you square root that, you end up with 41 meters. So A plus B minus C has a size of 41 meters. So we know the size. Straightforward. The next question is, where is A plus B minus C located? Remember, along the x-axis, A plus B minus C has got a size of 9 meters. Then along the y-axis, it has a size of 40 meters. So if you sketch this, where is the sketch diagram? Here. If we sketch this here, along the x-axis, AX plus BX minus CX, this is 9 meters, it's positive. Then along the y-axis, that is AY plus BY minus CY, that is 40 meters, it is also positive. So we get this Y component, we shift it, we put it at the end of the X component, that's the dotted line there. So if we move from here, we move along the x-axis, then we move along the y component, we end up at that particular point there. That point is the same as this green line. This green line is what represents A plus B minus C. Okay, now we are in the first quadrant here. Now something interesting happens. The angle theta from the positive x-axis, to where the vector is, that is your theta. From the positive x-axis to where the vector is, this is your theta. This is the angle we are looking for. However, if you decide to create a triangle, you create this triangle along the x-axis 9 meters, then the opposite 40 meters, then the adjacent, the hypotenuse, this 41 meters, what you end up is a triangle. In this triangle, the angle of the triangle phi, which is not shown, is also this same angle, which is your theta. So in this triangle, the angle of the triangle phi and theta are the same size, and they are measured the same way. Phi is measured from the positive x-axis anti-clockwise. Your phi is also measured from the positive x-axis, now it's measured anti-clockwise. So these angles, theta and phi, when you are in the first quadrant, they are the same. That's why I have only shown one angle there, which is theta, because the angle of the triangle is the same as the angle of the vector from the positive x-axis. Is this clear? Okay, I'm not getting a response. So I'll proceed to work out the angle of the triangle. I'll just work out tan theta. So tan theta is going to be equal to AY plus BY minus CY divided by AX plus BX minus CX. So AY plus BY minus CY is 40 meters divided by AX plus BX minus CX, which is 9 meters, and this gives you 4.4. That. Then theta is going to be tan inverse of 4.4, and that's going to give you theta of 77.3 degrees. So the angle which the vector makes with the positive x-axis is 77.3 degrees. And we have come to the end of this topic on scalars and vectors. Are there any questions? Is it clear on what you're supposed to do?
Yes. Yes, sir.
Okay, so I need to admit someone at the very end. Any other questions? If you have a question, otherwise we have to come to the end of this topic. So next week we'll start a new topic. We'll start how to describe motion. Okay, so if there are no questions, then I have to stop sharing and wish you all of you a happy weekend. See you next week. Okay, the recording is going to be uploaded to YouTube and then Moodle for you to refer to at any point during the